it is uncharged body, it will be divided equally. So q by 2 plus q by 2 equals to 3q by 4. So now force on A, B, C. So A, this is B, and in between C. Force on this one and this one. Distance is r by 2, r by 2. Q by 2, 3q by 4, 3q by 4. Now we can find here F1 and F2. So F1 will be kq by 2, 3q by 4 by r square by 4, and F2 will be kq by 4, sorry, 3q by 4, 3q by 4 by r square by 4. If I take net force F2 minus F1, because both are opposite direction, that's why. So K is common. R by 4 is also common, r square by 4. 3 by 4, 3 by 4, q by 4. So 3q by 4 is also common. So we are left with q by 2, 3q by 4 minus q by 2. So we'll get 3kq square by 4r square. So this is your force formula. We'll get here 3 by 4 F. Chandana, able to understand?
Yes, sir.
So we are just using properties of the charge. Let's do second one. Two identical positive charge Q, each are fixed at a distance 2a apart from each other. Another point charge Q naught with a mass m is placed at a midpoint between two fixed charges. For a small displacement along the line joining the fixed charges, the charge Q naught executes simple harmonic motion. Okay. To be in simple harmonic motion, let's keep this object, like suppose this is Q charge here at distance okay, let's take Q here. So A and A. So this is your point, suppose X here, it has to move here. This much distance. Midpoint with charge, execute. Okay. So force on Q, like it will be like a difference of this one. So K, this is your X distance. Let's take this one. K, Q, Q naught, because Q naught by total A minus X the whole square. And second one, K, Q, Q naught, X plus A the whole square. It is like similar way like the axial point formula. So if we combine this, total force will be K, Q is common here. 1 by 4 and this one. If I with this one, if I multiply and divide by 4ax divided by 4ax, so this will be x square plus or a square plus b square or x square plus 2ab, 2ax. So this will get cancelled. We're left with 2ax. So this will become same. Yes, fine. So what I'm doing here, I'm taking this kq cube common outside. So here I'm taking 4ax divided by a minus x square, the whole square again. The whole square again. I'm just splitting this term, a square minus this one. So AB to AB. And this one I'm multiplying and dividing by 4ax to make these things common. Okay, then that's simple term. That's it. Now, actually, this distance, this A distance is like a very, very smaller than x or greater than x. X. So this x can be neglected. So we will left with f equals to k q q naught. X can be neglected in the sense this way, not in like numerator. Numerator is multiplication. It cannot be neglected. 4ax by a to the power 4. So 1a can be cancelled. So 4k q naught x by a cube. That is net force. Okay, this is not yet over because this is not in our option. We need here 1 by 4 pi epsilon naught. That is okay. Then what we need here, we need to introduce mass also. Okay. So simple harmonic motion. To be in simple harmonic motion, we need F equals to m omega square x. So this force I can equate with this one equals to m omega square x, x cancel. So m divide. So where we are getting divide by m, that is our answer. So omega equals to 4k q naught by m a cube. Then time period will be reverse. This is time period, right? SHM time period of this oscillation will be reverse of this one. So m a cube and k is there. This is what 1 by 2 pi. Okay, 1 by 2 pi. See omega, you know, time period for omega in relation of the time period is 2 pi by t. 2 pi by t. So 2 pi if I take it inside and 1 by 4 pi and t square. So this will become let's k equals to 1 by 4 pi omega. Sorry, epsilon naught. So it will be 4 pi. If I'm bringing this inside here, this pi inside will become pi cube. Pi cube into epsilon naught m a cube. Okay. Then q naught under root. Okay, this much long. Option number A.
So how is it pi cube? Shouldn't it be pi square?
Yeah, but if I'm bringing pi inside, this is outside, right? Outside the cube square root. If I'm bringing inside, it will become pi square. and pi is already there. K is what? 1 by 4 pi. So pi and this pi square will become pi cube. This pi is already there. I have to understand what I'm saying.
Yeah, I got it.
And this 4 and this square and this will be outside, it will become square. 2 and 2 will get cancelled. So we are left with this 4 as it is. This 4 is as it is. Chandana?
Yes, sir, I got it.
Okay. See this, I know like it's a little bit long for this JEE question, but yes, you have to
So
solve
the
when it
answer
is
is
like,
option A.
I'm sorry, what?
The answer is option A.
Okay, yeah. Option A. Check this question, how we did, how we started, and what was the conclusion. See, first we have two charges, so we just followed our usual thing like force equals to k cube q by r square. Then we got somewhat force. We compare with omega because we know omega equals to 2 pi by t. So force and omega comparison is this way, rotational. See, that's why like we need to know everything before doing any chapter. We need to rotational motion because rotational will come here, oscillation will come here. Okay, let's see the third question. What it says. Okay, third question, I think so it will be easy. Or like charge 4, it's to be divided into 2. Okay, fine. The distance between two divided charge is constant. The magnitude of divided charge is so that force between them is maximum. Fine. Suppose one charge is q, another charge will be 4 minus q. That's it. So when can charge be maximum? Oh, sorry, not charge. Force be maximum when dq by df by dq will be 0. That's it. Over. That question is done. So third question, F equals to k q 4 minus q by r square. So we want F to be maximum. That means df by dq should be 0. Now we have to differentiate this one. df by dq should be 0. So if we differentiate this one with and compare with 0, so k and r square is constant. So four minus 4q minus q square. So it will become 4 minus 2q equals to 0. So this whole thing we can send it to 0. So 4q equals to 2. That's it. Ask me doubts.
No, sir.
Any problem?
No, sir.
Chalo. Fourth, today's our target should be all these questions should be done. Okay. So fourth, what it says, a 2-point charge Q are placed at a distance d apart. Third point of charge is placed distance x from a midpoint charge perpendicular bisector, the value of x charge will be experienced maximum Coulomb force. Okay, so where we'll get maximum Coulomb force? That's what we need to find out. By the way, where it is kept here, point charge places a distance d apart. X from the midpoint. So okay, x from the midpoint means they are talking about equatorial, like not axial point, equatorial point. So this is Q. This is also Q. This is midpoint. D by 2, D by 2. Okay. This is charge Q. This is chota Q, distance X. Theta distance, or this is your theta angle. So force F here, this also force F here, due to this one, both will be same. So let's do here same, net force. Okay, net force will be cos component here. Suppose if I take cos component here, and this also cos component here, so it will become same direction, 2F cos theta. Now what is F here? 2KQ, Q by, okay, distance we need to find. So what is this diagonal? How to find this diagonal? Girls, are you able to follow what I'm saying?
Yes, sir.
Yes, sir.
Okay. So how do we find diagonal? Tell me. How do we find diagonal? No idea? Yes or no?
No, sir. Can you explain it once?
See this diagonal Q and capital Q. How to find? We have this value. We have this diagonal, means length. We have this distance. We have this distance. We have this distance. How do we find this way?
Okay, this Pythagoras
Yeah.
theorem.
Exactly. So by Pythagoras theorem, this will be d by 4, d square by 4 plus x square, right?
Yeah.
So that is our distance, because we have found here force, both sides will be same. So this will be square of this one. What is the formula? KQQ by R square. So x square plus d square by 4 dot cos. How do we find cos? Perpendicular
Hypotenuse.
base by hypotenuse. Yes. X square plus d square by 4 under root. Or let's write like this, 1 by 2. That's it. 2KQQX by, if I add this one, it will become 3 by 4. Sorry, 3 by 2. 1 plus 1 by 2 is 3 by 2. So x square plus d square by 4 will give you 3 by 2. Now again, what we need? They're asking to find maximum Coulomb force. Just now I said, what do we do for getting maximum force? Just now we did.
We differentiated and equated to 0.
Yeah. This time we are not going to differentiate with respect to Q. Here with this time we are going to differentiate with respect to distance, because they're asking with respect to distance equals to 0. Let's start differentiation, or let's take net force. So this KQQ is constant. Keep it, bring this to 0. No need to worry about this, guys. Just x
Sir,
by,
is it d by 2 root 2?
yeah, it is d by d by 2 root 2. That is option number 4th.
So can you just scroll a bit up? I'll just copy the diagram.
Yeah. This is 4. Okay. So if you differentiate and equate to 0, we'll get x equals to 2 root 2. How do you differentiate here? Use product rule. Take this as a up. Use this like a dot x square plus d square by 4 into minus 3 by 2. Then differentiate. You'll get answer. Okay. Okay. Let's go for 5th one. Aditi, will you finish this?
Yes, sir.
Okay. D by dx. Use product rule and equal to 0. That's it. So let's do 5th one. 3 identical charge balls of each of charge 2 are suspended from common point P by silk thread of 2 meters shown in diagram. Okay, they are equilateral triangles of side 1. So equilateral triangles. This shorter triangle is 1, 1, 1, bada triangle is 2, 2, 2. We need to find net force. Suppose this charge is here. At this point, another charge from here it is coming. Let's take F and F. And this one, Q. This point of interaction. These 3 are like so this is what triangle? Equilateral. So equilateral triangle. What's the angle of equilateral triangle?
It is 60 degrees.
So it is 60 degrees. So if I take net force on this one, I'm just taking 2 here. They have shown so many here, doesn't matter. No need to worry about that. Just see these 2 points. F of net will be F square plus, both are F's, right? Okay, so then F square plus 2 F square cos 60. But this is not what they are asking. They're asking ratio. So this answer, net force to the force F. So what is this one? 1, 2, 3. 4. Cos 60 is 1 by 2, right? So 1 by 2, 2 cancel. So total 3. 3f square by f. It will be root 3 by 1. So option number D. Any question here?
No, sir.
Now this sixth, it's very easy. 64 conducting drops of each of radius 0.2, 0.02. Okay, 64. So,
once can you scroll up?
oh, yeah. 64 chota drop equals to 1 bada drop. So ratio of Q by Q is 64. That is okay. That's not required. Now here, what is happening? Volume is volume is not changing. So I can just compare with volume. See, whenever this type of things comes like something becomes smaller or like that, just compare with volume. 64 into 4 by 3 pi r cube. This is fixed thing. R will be equals to 4R. So what they're asking, ratio of surface density. Okay. Sigma for big one divided by sigma for small. We can do that. So area, charge per unit area. So charge per 4 pi r square. Next, charge chota. Charge per 4 pi r square. So Q by Q equals to 4 pi r square, 4 pi r, 4 pi cancelled. So into by 4 is 64, right? And r square by r square is, this is also equals to 4r. 4 is 16. So into 1 by 16. Okay, done. That's it. Answer will be 4. 4 is to 1. So do we have option like 4 is to 1? Yes. Option number B. So what I'm doing,
So 1 minute, I'll note it down.
yeah, you can note that down. This will be there also in recording also. But you understood what I did here?
Yes, sir.
Because obviously that same question will not come, but you should see the trick what we did here and what they're asking. Okay, then try remove next two question.
Okay, so now you can scroll it down.
Sure. Aditi? Done?
Yeah, sure, done.
Okay. Try next two question. I want you guys to try then. So what about seventh one? Any idea? How will you start? How will you approach? What they're saying to identical. Now they are considering friction also. Coefficient of friction is given 0.25. So this object, suppose moving, it's going force here, and friction force opposite. And this, if it is in this direction, friction force is this way. So in short, that force, if it is moving, should be in F, like friction force, and this equilibrium force should be equal. Then only they will balance. Otherwise, it will keep rolling or keep doing. So here, this force we can write here kq square by r square here. What's the distance? L. And small f is your frictional force. So frictional force formula mu n. N is your mg. F equals to mu n. And n is your mg. That's it. L equals to kq square by mu mg. Substitute the values. So if I take this outside, then it will become 9 into 10 to power 9 divided by 0.25 into 10 to power minus 2 into 10. This is under root into 2 into 10 to power minus 7. That will be your answer. Eighth one is easy. Eighth one is your homework. I guess it is easy. Okay, I think so. Yeah. Eighth one is homework. Okay.
Okay, sir.
Check what option it is. And tomorrow, like, we need to have some composition class of day before yesterday. Then shall we have it at 10 o'clock or 11 o'clock?
So 11 is fine.
Okay. You won't get up early?
No, sir, I have a lot of homework given.
Okay, homework. Okay. Okay, fine. What about you, Chandana?
Okay, sir. 11 is fine.
Okay, then. 11 to 11:45 something we'll have. Okay. See ya. Finish that question one.
Okay, sir.
Last question. Yeah. Okay. Bye-bye.